Hello friends, this is Gangadhar from the YouTube channel Maths Ganga. Do subscribe for the channel to get the latest updates and the solutions for the latest examinations and to know or to learn the different mathematical concepts. Okay, don't forget to subscribe the channel and then click on bell icon also. Now in this video I am going to discuss about the divisibility rules for the composite numbers using the divisibility rules of primes what we discussed in the earlier videos. Okay, see already certain videos are completed in this channel related to the divisibility rules. Okay, I suggest you all to follow those videos also. Okay, now in this class we are going to discuss about the divisibility rules for the composite numbers. And before going to know the rules for the divisibilities of composite numbers, we need to observe an observation regarding the division algorithm. Okay, see, if you suppose what I am saying is, if a number n is divisible by the product AB, okay, a number n is divisible by AB means, so when n is divided by AB, it leaves remainder 0. Okay. Then we can express it like using the statement of division algorithm, dividend is equals to divisor into quotient plus remainder. So this n is equals to divisor AB into some quotient plus remainder is 0. Okay. Since n is equals to AB into Q, what it conveys until if n is divided by A, it leaves the remainder 0. In the same way, if n is divided by B, also it leaves remainder 0. That means if product A into B is a factor or divisor of a number, then A as well as B both are the factors of the number. Okay, see, it is a clear observation. Okay, if 12 is a factor for a number, then automatically 3, 4, 2, everything is a factor of that number. Right, now it's canvas whether it is true or not. Okay, see, what I am going to ask you is, if n is divisible by A leaving remainder 0 and n is divisible by B leaving remainder 0, then if we divide n with the product AB, then what about this result? Whether this result is, whether the remainder is 0 or not, we need to check. Okay, see, to conclude the statement whether n is divisible by AB or not, if n is divisible by A and B, we are going to check with certain examples. Okay, see, I am taking 12 instead of n. 12, okay, 12. Here also 12. I am taking 12 instead of n. And then I need to take two numbers. I am taking 2 and 4. See, we know that when 12 is divided by 2, it leaves remainder 0. When 12 is divided by 3, it leaves remainder 0. Okay, and when 12 is divided by 6, in this case also it leaves remainder 0. Okay, so finally what I am going to conclude, since 2 leaves remainder 0 when it divides 12, okay, when 3 divides 12 also it leaves a remainder 0, and if 12 is divided by 6 also it leaves a remainder 0. Okay, this is one case. And by taking the same number 12, if I readjust A and B, if I take A as 2 and B as 4, then what will happen? When 12 is divisible by 2, it leaves remainder 0. When 12 divisible by 4, it leaves remainder 0. A into B, 2 into 4 is 8. Okay, when 12 is divisible by 8, it won't leave remainder 0, it leaves remainder 4. Okay, in the previous case, 2 and 3 are factors of 12. 2 into 3 also a factor of 12. In this case, 2 and 4 are factors of 12, but 2 into 4 is not a factor of 12. So finally what we conclude? We will conclude that if A and B are the factors of n, then A into B may or may not be a factor. The remainder, okay, may be 0 or may be not equals to 0. Okay, so if A comma B are divisors or factors of a number n, then A into B sometimes is a factor and sometimes is not a factor. Okay, how we concluded? By taking two examples. Okay, and by observing those two examples, what I am going to conclude is 12 divided by 12 leaves remainder 0, 12 divided by 3 leaves remainder 0, and 12 divided by 6 leaves remainder 0, and 12 divided by 2 leaves remainder 0, 12 divided by 4 leaves remainder 0, but 12 divided by 8 leaves remainder 4. Okay, see, by observing these two, okay, with the keen analyzing of these two examples, and if you do by taking different numbers instead of n as well as different values instead of a, b, finally what you conclude is, in this case the remainder is 0 possible, in this case the remainder is not 0. So what is the speciality on this 2 and 3, and what about 2, 4? If you observe, here 2 and 3 don't have any common factors, but whereas in this case 2 and 4 have a common factor. There are no common factors for 2 and 3, so the product 2 into 3 again leaves remainder 0, but here 2 and 4 have common factors, so 2 into 4 won't leave remainder 0. So finally what I am going to conclude is, if a comma b are factors of n, then a into b is also a factor of n if a, b have no common factors. If a, b have common factors, then it won't leave remainder 0. Okay, so in conclusion, we need to check by taking different examples instead of n as well as the place of a, b, and by observing all those examples we can analyze and we can conclude that, okay, and if n is divisible by a and b, then n is divisible by a, b also if a comma b have no common factors. Okay, finally in this class what we discussed is, if n is divided by ab leaves remainder 0, then what will happen? Then when n is divided by either a or b leaves remainder 0, this is an obvious task, no need to discuss, the clear idea. But whereas in the other case, if n is divisible by a and if n is divisible by b, then n is divisible by ab also whenever if a comma b have no common factors. Okay, using this logic we can generate the divisibility rules for different prime numbers, different composite numbers. Already we discussed the divisibility rule for so many different prime numbers till 11, and in this video we are going to discuss the divisibility rules for different composite numbers using the rules of those primes, and in the coming videos we are going to discuss about the divisibility rules for the other prime numbers like 7, 13, 17 like that. Okay, now using this logic and by the idea of the previous divisibility rules, we are going to say the divisibility rules for different numbers here. Okay, see, coming to number 2, a number n is divisible by 2. What is the divisibility rule for 2? We discussed in the earlier video. A number is divisible by 2 if its units digit is divisible by 2. If its units digit is an even number, then we say a number is divisible by 2. And we know a number is divisible by 3 if the sum of the digits is divisible by 3. And a number is divisible by 4 if the last two digits are divisible by 4. A number is divisible by 5 if the units digit, that means the last digit, is divisible by 5. And a number is divisible by 6. Now here 6 is a composite number. Okay, since 6 is a composite number, a number is divisible by 6 if it is divisible by two numbers such that whose product is 6 and the numbers don't have any common factors. Okay, I am taking 2 and 3. 2 into 3 is 6 and 2, 3 have no common factors. Then by the previous observation we say that number n is divisible by 6 if it is divisible by 2 and 3. So what is the divisibility rule for 6? A number is divisible by 6 if it is divisible by 2 and 3. Why we selected 2 and 3? Because 2 and 3 have no common factors as well as the product is 6. Okay, and 7 is a prime number, keep away. And we are going to discuss the divisibility rules for these numbers in the coming videos. Then coming to 8, we have that the divisibility rule for 8 is the last two digits. A number is divisible by 8 if the last three digits are divisible by 8. Okay, and a number is divisible by 9 if the sum of the digits is divisible by 9. And we discussed certain examples also in the previous videos. And a number is divisible by 10 if its last digit is 0. Okay, and coming to the 11, a number is divisible by 11 if the difference between the sum of the digits in the even places to the sum of the digits in the odd places is either 0 or 11 multiple, then we say the number is divisible by 11. Okay, we have certain examples along with the statement in the previous videos. And coming to the next number, 12. A number is divisible by 12 if it is divisible by 3 and 4. Okay, see 12 can be written as a product of two numbers such that 2 into 6 or 3 and 4 also. If you select 2 and 6, the product is 12, but 2 and 6 have common factors. But whereas if you select 3 and 4, the product is 12, but 3 and 4 don't have common factors. So we need to select such numbers. So the divisibility rule for 12 is a number is divisible by 12 if it is divisible by 3 and 4. Whereas 13 is a prime. Coming to 14, a number is divisible by 14 if it is divisible by 2 and 7. A number is divisible by 15 if it is divisible by 3 and 5. The product is 15 as well as they don't have any common factors. Okay, and coming to 16, we have the divisibility rules for the powers of 2. Okay, see for 2 last digit, for 4 last 2 digits, for 8 last 3 digits, and for 16 last 4 digits we need to observe. If the last 4 digits are divisible by 16, then the total number is also divisible by 16. Coming to 17 is a prime, and coming to 18, a number is divisible by 18 if it is divisible by 2 and 9. Okay, we have to select 2 and 9 only. We can't select 3 and 6. Why? Because 3 and 6 have common factors. Okay, right. And then for 19 is a prime. For 20, we have to observe 4 and 5. So a number is divisible by 20 if it is divisible by 4 and 5. A number is divisible by 21 if it is divisible by 3 and 7. A number is divisible by 22 if it is divisible by 2 and 11. Whereas 23 is a prime. A number is divisible by 24 if it is divisible by 3 and 8. A number is divisible by 25 if the last 2 digits are divisible by 25. A number is divisible by 26 if it is divisible by 2 and 13. So like this we have divisibility rule for so many numbers. Okay, based on the divisibility rule for the prime numbers up to 11. Okay, see for example if you say 56, a number is divisible by 56 if it is divisible by 7 and 8. Why? Because 56 is the product of 7 and 8 and 7 and 8 have no common factors. So the divisibility rule for 56 is nothing but the divisibility rules for the 7 and 8. Okay, a number is divisible by something like 72. So if it is divisible by 8 and 9, then it is divisible by 72. Okay, and what is the divisibility rule for 143? 143 can be written as 11 into 13. So if a number is divisible by both 11 and 13, then the same number is divisible by 143 also. So like this we have divisibility for different numbers. Okay, so using this concept we are going to do certain problems. Okay, for example, if anybody asks you to say or to check whether the number is divisible by 15 or not, 201815. If I have a number like this, whether it is divisible by 15 or not, we need to check. Okay, whether it leaves remainder 0 or not, we need to check. So to check the divisibility rule for 15, we need to observe the divisibility rule for 3 and 5. Okay, so if this number is divisible by 5 as well as 3, then this number is divisible by 15, otherwise it can't be. It is not divisible by 15. See, coming to the divisibility rule for 5, we need to observe the last digit. If you observe the last digit, that is 5. Since the last digit is 5, so the number is divisible by 5 also. Then to check the divisibility rule for 3, we need to observe the sum of digits. If you add 2 plus 1 is 3, plus 8 is 11, plus 1 is 12, 12 plus 5 is 17. So sum of the digits is 17. Okay, 17 is not divisible by 3. Since 17 is not a multiple of 3, the given number is not divisible by 3. The given number is divisible by only 5. So the given number is divisible by 15, but given number is divisible by 5, but not by 15. So if you ask, anybody ask you, okay, the number is divisible by, and you have the options like 3 or option A, 3, okay, option B, 5, option C, 3 or 5, option D, 3 and 5. What you have to select? it is not divisible by 3. So we need to neglect these two. It is divisible by 5. So we may select these two. Okay, either 5 or 3 or 5 also we can select. Okay, but it is not divisible by 15. Okay, this is one problem. And I mentioned you two problems regarding the divisibility rules of these formats. Okay, the first one is the given number, they asked us to 214 3a b 89 is a number. Okay, this number is divisible by 99. So we need to find the values of AB. We need to find the pairs of AB. Since this number is divisible by 99, what it means? We can write this 99 as a product of 9 and 11, which have no common factors. So since this number is divisible by 99, this number also divisible by 9 and 11 also. So we need to check the divisibility rule for 9 as well as 11. Okay, see, coming to the divisibility rule for 9. What is the divisibility rule for 9? Sum of the digits is a multiple of 9. So add the sum, calculate the sum of the digits. 2 plus 1, 3 plus 4, 7 plus 3, 10 plus 8, 18 plus 9, 27. 27 plus, we don't know the digits of A, B. So 27 plus A plus B is a multiple of 9. Since we are checking the divisibility rule of 9, sum of the digits must be divisible by 9. So this is the sum of the digits. This sum must be divisible by 9. So this sum must be divisible by 9. So what is the value of A plus B? Since it is 27, surely this A plus B also must be either 0 or 9. If A plus B is either 0 or 9, then the summation is divisible by 9. So the chances for A plus B is 0 or 9. In the same way, we need to check the divisibility rule for 11. So what is the divisibility rule for 11? A number is divisible by 11 if the digits in the alternate places we need to observe. So coming to the units place, 9 plus B plus 3 plus 1. Okay, it's clear. 9 plus B plus 3 plus 1. That means 13 plus B minus 2 plus 4, 6 plus A plus 18, which is nothing but 14 plus B. This must be 11 multiple. And if you simplify, 13 minus 14 is 13 minus 14 minus 1. Here it will be 14A, 2 plus 4, 6 plus A plus 14 plus A. And what will be 13 minus 14, and then B minus A minus 1 is equals to 11 multiple. What is the value of B minus A? Okay, the value of B minus A, since the difference is 11 multiple or 0, 11 multiple or maybe 0 also. So how can we write B minus A? If B minus A is 0, no, B minus A is 1. If B minus A is 1, 1 minus 1 is 0, so the given number is divisible by 11. In the same way, if B minus A minus 1 and 11 multiple, whenever it possible. Okay, see, and A are the digits, we can't go for the negative numbers. Okay, now see, B minus A is 11 and A plus B is 0. This is A plus B, this is B minus A. A and B are the digits. Sum of the two positive digits is more than the difference. Okay, since A plus B is either 0 or 9 and B minus A is 1, we need to select 9 only instead of 0. Why? Because the sum of the two numbers is more than the difference. So if A plus B is 9 and B minus A is 1, then what are the value of AB? So A plus B is 9. So B plus A is 9. And if you solve, if you add, 2B is equals to 10 and B is equals to 5. Since B is equals to 5, then what is the value of A? A is equals to 4. So what are the possible digits instead of AB? A is 4 and B is 5. So this is the problem. So once again, if you check, the question is, this number is divisible by 99, then find the digits in the place of AB. Since this number is divisible by 99, the divisibility rule for 99 is 9 and 11. So this number should be divisible by 9 and 11. So since it is divisible by 9, sum of the digits must be a multiple of 9. So sum of the digits is a multiple of 9, so that A plus B is 0 or 9. In the second case, when you check for the divisibility for 11, see, this is the divisibility for 11. So if you are from this, if you observe, you will get B minus A is 1. After having B minus A and B plus A, we can simplify to get the values of AB, whereas A is 4 and B is 5. This is the problem. Okay, and I have one more problem here. What are the values of X and Y if that number is divisible by 24? 8, 7, 6, Y, 5, X, 5. If it is divisible by 24, it leaves a remainder 7. Okay, in the previous case the remainder is 0, but in this case the remainder is 7. Then they ask us to calculate the values of x and y. How can we have to calculate? See, 24 it is given. 24 is a product of 3 and 8. Okay, whereas 3 and 8 have no common factors. So we need to check the divisibility rules for 3 and 8 to solve the problem, right? So what is the divisibility rule for 3? Okay, see, the remainder obtained by dividing a number with 3 is nothing but the sum of the digits. See, here it is mentioned as 7, right? And we have the divisibility rule for 8 also. What is the divisibility rule of 8? A number is divisible by 8 if the last 3 digits are divisible by 8. First of all, check with the divisibility rule of 8. To satisfy that this number, to leave a remainder 7. Okay, to leave a remainder 7, you need to check the last 3 digits. So consider this 5x5. Okay, we need to replace this x with different digits like 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So that if you divide the last 3 digits, it has to leave a remainder 7, not 0. Okay, right. If you replace this place with 0, okay, what we have here? Last 3 digits, 5 and then 5. If you replace this place with 0, then do divide with 8. What will happen? 8 6 is 48. Okay, and you left with 25. 48 and 25, 8 this is 24. It is leaving remainder 1. So 0 is not possible. If you place 1 here, okay, 5 1 5. 8 6 is 48 and you have 35. Okay, right. 8 6 is 48 and then 35. So since it is 35, 8 4 is 32, leaves a remainder 3. So this is also not possible. You have to get the remainder 7. And if you replace with 2, okay, see 0 is not possible, 1 is not possible, 2, 5 25. So what? 8 6 is 48 and then we have 4, 45. For 45, 8 5 is 40, leaves remainder 5. So 2 is also not possible. So replace with 3, 5 35. So 8 6 is 48 and then still we have 5, 55. And then for 55 if you check 8 7 is 56, 8 6 is 48, 48 and then 55. Okay, again it leaves a remainder 7, I think so. Check once again. 8 6 is 48 and then you have 5, 55. 8 6 is 48 and then 55. So it leaves remainder 7 if the number is 3. So the value of x is 3. So we need to fix the value of x as 3. And check for the other numbers also. Replace with 4. What will happen? 8 6 is 48 and it is, and the balance is 6, 65. 8 8 is 64. Leaves remainder 1. 4 is not possible. Then replace with 5. Okay, see 8 6 is 48. Okay, and then we have that 275. 8 9 is 72. Leaves remainder 3. Not possible. And replace with 6. 8 7 is 56. Leaves remainder 5. Not possible. 575. 8 7 is 56 and then 1 5. 8 1 is 8 and then leaves remainder 7. So 7 also possible. Okay, in the same way 8 9 also not possible. So we need to replace x with 3 or x with 7. We have two possibilities for x. Okay, how we fix the values of x? Speak once again. They mentioned that the given number is leaves a remainder 7 when divided by 24. Whenever it leaves a remainder 7, when it is divided by 24, so to check the divisibility rule of 24, we need to concentrate on the divisibility rules of 3 and 8. What is the divisibility rule of 8? A number is divisible by 8 if the last 3 digits are divisible by 8. So concentrate on the last 3 digits. Okay, so we need to fix the value of x such that if the last 3 digits are divisible by 8, divided by 8, it has to leave a remainder 7. Okay, so to get remainder 7, I am replacing different digits in the place of x from 0 to 9. Since these are the digits, I need to check with the digits. If you replace either with 3 or with 7, when divided by 8, it leaves remainder 7. So the possibilities for x are 3 or 7. So the possibilities for x are 3 or 7. Now, in the other case, to check the divisibility rule of 3, we need to observe the sum of the digits. So to check the divisibility rule of 3, observe the sum of the digits, add everything. 8 plus 7 is 15. 15 plus 6 is 21. And plus 10, 31. 31 plus 5 plus x. Okay, we need to fix the values of x. If it is, we are checking divisibility rule of 3. So sum of digits must be multiple of 3. So fix the values of x. We have x as 3 or 7. So if x, we have two chances from here. If x is equals to 3, 34 plus y. If x is equals to 7, then it is 7 to 38 plus y. We need to fix different values in the place of y so that the summation is a multiple of 3. Right? See, 0, 34, not possible. 1, 35, not possible. 2, 36 is a multiple of 3. 3, 37, not possible. 4, 38, not possible. 35, 5, 34 plus 5, 39 is a multiple of 3. 6 not possible, 7 not possible. If you replace with 8, 34 plus 8, 42 is a multiple of 3. And then 9 not possible. So the possibilities for y are 2, 5, 8 whenever x is equals to 3. And in this case, if x is equals to 7, we have 38 plus y, we have to replace. If you replace with 0, it is not. 38 plus 0, 38 is not multiple of 3. If you replace with 1, 38 plus 1, 39 is a multiple of 3. Okay. Replace with 2, 40 is not possible. Replace with 3, 41 not possible. Replace with 4, 42 is possible. Again, if you check, if you replace with 7, 45 is also multiple of 3. So we have 1, 4, 7 in the place of y, so that the number is divisible by 3. Okay. I love the logic. Since I mentioned to get the remainder 7, when it is divided by 3, it has to leave a remainder 7. See, when divided by 3, leaving remainder 7, nothing but if you divide 7 into 3, it has to leave remainder 1. So, whenever if you replace different digits in the place of I, it has to leave a remainder 1. Okay. So, further we need to check, not 3. If you replace with 3, 34 plus 3, 37. When it is divided by 3, leaves remainder 1. If you replace with 6, 34 plus 6, 40, leaves remainder 1. Okay. And if you replace with 9, it leaves remainder 1. Here also. When you replace with 2, leaves remainder 1. Replace with 5, leaves remainder 1. And if you replace with 8, y with 8, 38 plus 8 is 46. If you divide with 3, it leaves remainder 1. Okay. Leaving remainder 7 when divided by 3 is nothing but leaving remainder 1 divided by 3. So these are the possibilities in the place of 5. So the possible pairs of x comma y are 3, 3, 3, 6, 3, 9. And here 7, 2, 7, 5, 7, 8. So there are totally 6 possible pairs are there for x comma y. So that the given number is divisible by 24. Okay. By observing or by analyzing the divisibility rules for the different numbers, we can calculate such type of problems which are regularly asked in different competitive examinations. Okay. And I suggest you to follow the remaining videos also to get a clear idea about the divisibility rules. Don't forget to subscribe the channel, and I hope this video is helpful in your preparation. Do subscribe, do like it, and then refer it to your friends also. Thank you.